Hopefully everybody's already got the title written down. In case you're wondering what this is called, it's called initiative. Inscribed angles. Angle ABC is called a what? Nope. I will not tell you. I want you to keep it to yourself. Try to answer this blank. Look back. It is in the previous sections. It is a very important thing that we need to know. And when I was talking to other classes, I realized this is something that if we don't know, I'm going to need to require you to, I was hoping we'd gotten this earlier, but this is very important. You have to be able to. It's called a central angle. Why is it called a central angle?
Because it's from the angle from the center.
What is this thing called, though, in geometry words? The vertex of the angle is on the what? Is on the center. If the measure of this is 60 degrees, if the measure of angle ABC is equal to 60 degrees, the measure of arc AC is equal to what?
60 degrees.
They're the same, right? And that's when this is a what? What kind of angle? Central angle, okay? This is all review. Angle AEC is called a what? No, not inscribed circle. What separates it from, what do you think separates it from the central angle? What makes it different?
It's on the circle, not in the circle.
Vertex is what? On the circle. And you were kind of right, but not completely right. Vertex is on the circle. What's the difference? What is the central angle? The vertex is
On the center.
on the center of the circle. Not just in the circle, inside it, but just on the center. That makes it a central angle. So you guys see the difference. New fact. You guys know what we mean by contains? An angle, in essence, looks like two arms grabbing something, doesn't it? And holding it in between it. What arc is angle ABC holding? AC. That is the arc it contains. What arc is AEC holding? AC. So, what would the measure of angle AEC be? Yes, it is that simple. Okay? I saw some of you looking like, 30? I mean, is it really that simple? Yes, it is that simple. It's always half the arc it. And when you're going the other way, if you didn't know, if I told you that was 30 and you didn't know what that arc was, what's that arc now? You just double it to go the other way, right? That's simple. And doesn't that kind of make sense? Isn't this kind of half what, half the distance or more away? Because if it's on the center at 60, once you stretch this thing out, you make it angle smaller, don't you? It turns out you make it half as small as the central angle.
It's bigger or what, it's smaller if I just spread that out
Because when you pull it, as you can see it, the
yeah, it's
the
not
two arms become closer together, don't they?
in the corners.
That is what this section is in essence. It's what this section's about. Now, you have to know this. We'll use this fact to have some little bit harder problems than just saying one, if that one's 100, that one's 50, or vice versa. I mean, there are some other situations that we can talk about. Let's draw another picture. Can you guys look at that picture and tell me anything? Yeah. Answer me this. Why did I use two different colors? I was trying to lead you somewhere, was I not?
Two different engines.
I was trying to, because, it's easy. Looks like a crooked hourglass, you could say. There's all kinds of different things you can say about it, isn't there? But I drew those in two different colors for a reason. I wanted to lead you towards seeing that there are two. What is this section about? inscribed angles. So what did I try to lead you to there?
Oh, they're two different.
They're two different what? Inscribed angles there. Is there anything you could tell me about those angles? Nope. It's not the word I'm looking
Pass the
for.
scepter.
What,
You can't see the two colors.
oh, okay. 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 How about I do this? It's okay. I didn't necessarily expect you to see it. What am I trying to lead you to now?
They're both the same measure because they're using the same,
Ah.
same mark.
What do both, excuse me. Let's stay focused up here, please. What, I told you that an angle's like two arms, and it contains an arc, right? What arc is angle AB, the red one, holding? We know it's half of that arc, right? What arc is the black angle holding? Are they holding the same arc? Isn't, so then isn't the half of the same thing going to be the same thing? No matter what this arc is, whether it's 200, that one's 100, that one's 100. If it's 50, that one's what? 25, that one's 25, so on and so on, right? So what we're saying is, if two inscribed angles contain the same arc, what do you think we can say about it? That they have to be what? Congruent. So how could we write that? If two inscribed angles contain the what? Same arc, then the angles are what? Congruent. You kind of, you could almost lead yourself to that. Doesn't that make sense? You know, I had to kind of lead you there. But so, yes, we need to write it down, but it shouldn't be something that's that hard to remember, because it just flat out makes sense. This is another one of those that we have a theorem for, that I want to see if you guys can figure out what that theorem probably is. And I'll try to lead you there again. Here we go. I'll even go so far as to draw another circle. Where am I trying to lead you? How about this? Look at the, what did I try to make reference to you here where I said I was trying to lead you? By the what? Colors, right? What did I do different this time that I'm trying?
The dotted line.
I made a dotted line there. Why would I do that? Well, I'm trying to, usually a dotted line we're trying to say is something I want to say is there, but almost transparent, like you don't kind of see it. But I want to show that it's there. So basically, I'm wanting to show you that XZ and AC are what? Diameters, right? Would everyone agree?
Yeah.
But yet I'm wanting your focus to be on the what?
Other two.
The angle. If I wanted the focus to be on a triangle, I probably would have colored that in, wouldn't I? So I'm still, what is this section about again? So what am I wanting you to focus on here? Probably the what? Inscribed angle. See, this is a little part of just psychology of math, or just understanding, you know, what they're doing, you know, what's significant about a diameter? What does it do to a triangle or a circle?
Find the circumference, the size of the circle.
Answer that question. What do I put in blank?
Diameter.
What am I usually talking about? I'm talking about a arc. Do I have to tell you what the measure of that arc is? Thank you. What is the measure of that arc? You don't have to have the central angle, or basically if it's a diameter, the arc contains it as what? 180, right? Okay, then where am I still trying to lead you? Can you please tell me? What is this section about again? So, tell me about an inscribed angle. Tell me something.
The arc.
Why? Why do I know it's 90 degrees for sure?
Because it's half the arc.
Because it's holding half the circle, right? And inscribed angles are always half of the measure of this arc, right? So, I know that has to be what? Half of? We have a theorem about this in this section. That inscribed angles that hold the, or whatever however they say it, hold the diameter are obviously always going to be what? 90 what? Degrees. Because if it's holding a semicircle, if it contains a semicircle, then of course it has to be half of 90. But that's really just an extension of saying what? Inscribed angles are always equal to what? Half the measure of the arc it contains. This one contained half the circle, which means it contained 180 degrees, and half of that is. So you see what I mean, that you don't necessarily need a theorem to point you there. But what do you think they're going to do in a lot of these problems? Are they going to tell you this is 180? They're going to expect you to see that and assume that's 90. And then later on might want you to make reference to the fact that this is a what kind of triangle?
Right triangle.
And then we can do fun things again, like what? Pythagorean's theorem. Special right triangles. Trig functions. Let the fun begin still again. Hence why we're doing chapter 10 right after chapter 8. Right? Because we just did that other stuff. Make sense? Now let's apply this. Let's get out our little red books. Quickly do some problems. On page 129. Hey, if that one's 23, and this is an inscribed angle, how does it relate to the arc it contains? Inscribed angles, are they equal or are they half? Half. So what does this angle have to be then? This is half of this, so what is this? 40 what? And that's what they ask us to find, right? Think we can do that, can't we? Inscribed angle or central angle? Okay, inscribed angle or central angle? How does it relate to the arc it contains? So, what is the arc it contains? What is the arc it contains? 162, so it has to be what of 162? So that makes this. That's hard. Number 3. Oh, they're trying to make things hard on you. But what have you known for all of your life? When you turn around in a circle and start getting dizzy, one time around is what? 360. You've known that for a long time. So 120 and 140 is what? 260. So how many degrees are left for this arc right here? Oh, inscribed central. So what is it to its arc? So what does it make this angle? They got a little crazy with that one, I know. Arc MB. Well, what, inscribed or central? Inscribed. So what's that? Crazy.
Oh, and then PN is the diameter.
Oh, now they're getting crazy, aren't they?
We're supposed to find the arc of MP on number 4, so we're supposed to find a different arc.
Oh, crazy.
So PN's diameter is 180.
See? Don't pay attention, make stupid takes, like I just did. Keep going on. I might have done on purpose, but might not have. You don't know. Crazy. All right. Let's go down here to number 5. Okay. What's the section about? Inscribed angles. Is there anything that we can relate with a couple of inscribed angles here? Both these angles hold MN, don't they? Now, does that allow me to have an equation? Okay, what is my equation? 6x has to equal what? Once I find x, I'll be able to find p, and they want me to find L. So that helps me for number 7, doesn't it? I'm assuming, let's see, that I don't understand why they can't put like a line or something to kind of help separate those right there. Because that's what I see. Isn't it inscribed here? And it holds LP, arc LP. Is there another one? M is an inscribed angle. What does it hold? So what do these two have to? It is hard for some people, it's easier for others, hard for some, to be able to kind of block everything else that's going on in this picture out of your mind and just see what. Hence why you probably. Does everybody see that? Because aren't these two congruent, so these are equal? I'm going to get 3y equal to 9. Everybody see how we got that? L. I've got to find what to find L? X, right? X is equal to what? You know, tonight when you're home working on this and be able to understand what we're looking at. Not a whole lot of difference in 6 and 8. So we'll do 9. This is 10 point what, 4? Okay, no, it doesn't. So how in the world am I going to relate all this stuff to where, because if I find X, I find the things I need, right? Well, how am I going to find X? Nope.
No,
I
5x
said they're not
minus-
necessarily equal.
5x minus
And then
2
don't
plus
fall into that trap that always when you see things that look like X's in them, oh, they're probably gonna be equal. It's not always
5x
5x minus 2 plus 2x plus 8 plus 90 equals 180.
exactly. This is a triangle, is it not? The three angles in a triangle will always add to. So I can say 90 plus what? 5x minus 2 plus what? 2x plus 8. So that means we did it correctly. Oh, I'm sorry. Do you guys like it when I take little screenshots of these? Or is it just as easy to pull up the video?
I like the screenshots.
You like to have the screenshots so you can quickly get to some things? Okay. It doesn't matter. Angle U is holding the other part of the circle, but together they hold what? 360 degrees, and since they're always half of it, that means together their angles have to add to 180. So with that same logic, what about angle R and angle T? The measure of angle R plus the measure of angle T has to equal what? Because they hold together, they hold what? The whole circle, and the scribed angles are always half. So if it holds 300... Okay.
You underneath the rules of geometry, you don't have anything to disprove it.
What is the assignment? Anybody got Canvas out? So nicely tell me. 1 through 6.